Now let's look at some of the definitions of angles. You know all of these. We'll draw them in. An acute angle. Do you remember the definition? It's any angle that is less than 90 degrees, right? So this would be an acute angle, and it would be positive. A positive acute angle. I could have drawn a negative acute angle. Here's a right angle, and of course a right angle is exactly, that is a terrible looking straight line, and I could do this curved line here. We typically indicate that we've got a right angle by drawing that little box. So remember that? In this case, I drew a positive right angle. I could have drawn negative. An obtuse angle, well, we did acute, which is between 0 and 90 degrees angle measure. We did right, which is exactly 90 degrees. And obtuse, as you remember, is greater than 90 degrees and up to 180. So if I do a positive obtuse angle, there it is. How about a straight angle? Straight angle is exactly, I did really good that time, exactly 180 degrees. So let's go back here. In this case, your angle, and we'll call it theta, is greater than 0 and less than 90 degrees. A right angle, theta, is equal to 90 degrees. For an obtuse angle, theta is greater than 90 degrees, less than 180 degrees. And for a straight angle, okay. Complementary angles, let's just draw some examples of complementary angles. What do they have to add up to? They have to add up to 90 degrees. So I could have this angle here and this angle here. Since they add up to 90 degrees, they're considered complementary. For supplementary, they add up to 180. So if I had this angle here and this angle, I would have supplementary angles. One of the things you should notice here, unless the supplementary angles are both right angles, 90 plus 90, you're always going to have one obtuse and one acute. Coterminal angles. Oh, this is a good thing to talk about. Suppose I have this angle here, which looks to me, let's say it's 45. And one of the things you better be careful of, my drawings are not necessarily precise, but we're going to say this one is 45 degrees. All right. And over here, I'm going to say that this angle is, now don't be blown away by this, let's hope I get my math right, 405 degrees. Anybody have any idea how I get that? It looks exactly the same as my 45-degree angle. So let's try it. I go all the way around for 360, and then I add that remaining 45. So these are actually different angle measures, very different, aren't they? but they are called coterminal for, I think, pretty conspicuous reason. Their terminal sides are identical. We could do other things with these as well. Let me show you another one, which is a little more interesting perhaps. I could go, from my initial side, I could go negative. And what would that? That would be negative 315 degrees. We're going to talk a lot more about negative angles coming up. But notice that when I just look at the initial side and the terminal side, they look identical when you've got coterminal angles. We do have a problem here. We're going to face it very soon. The input variable in any trig function is an angle measure. We have up to this point always measured our angles in degrees, or for some of you, usually measured our angles in degrees. Degrees have no relationship to linear, do they? If I tell you that we've got a 45-degree angle, that doesn't tell us anything about the length of the rays, or if we're drawing a circle, I should say the radius of that circle. In a trig function, we've got an input, which is an angle measure, and an output, which is a real number. We need a unit of measure for angles that relates to the length. Oops, that's not going to show up there. The length dimensions of circles, so that I can talk about the circumference, I can talk about the radius. It's going to be very important.